Good evening, all. Hope all of you have attended the quiz. So we are about to start the session. So today we are having Nirmala with us for the session. Nirmala,
Yes.
okay, you may please start the session.
Okay. Is my screen visible?
Yes, it's
Hello.
visible.
Okay. So good evening, everyone. So in the previous session, we have learned about the basic drafting for a file for doing its estimation using estimax. And in this session, we will be covering the remaining portion to be completed in drafting for proceeding estimation. So for that, I'll be showing you an example for already completed file, which is SR 1446864. And while doing an estimation, we'll also be provided with an Excel file like this, containing the basic details of the building we are dealing with. So, and we should also do the drafting as per the requirement mentioned in this Excel file. Like if we look onto this, we can have a basic idea of the structure, that is whether it is framed or load bearing, what is the dimensions of the column that we need to provide, whether the sunshade has to be provided or not, and so on. So all these basic details will be obtained from this Excel sheet. And here, this is the drawing that is provided by the client without any layer correction. And if we obtain one such drawing, we need to convert this format into one such format that are required for the estimates to understand. So we need to provide some basic layers into this drawing. So once we get some one such drawing, we need to delete all of these unwanted things such as these figures and hats and all. And we need to provide the lines into different set of layers that are required as per the requirement of the estimates. So before moving on to the different set of layers, let me show you the different layers you need to deal with. So the layers can be basically divided into two. That is one set of layers that has to be drawn using the command polyline, and the other set of lines that has to be drawn using the command line. So first I'll be dealing with the set of layers that has to be drawn using line command. So one such layer is wall. So if we move on to this figure, we can see that um, before that, let me explain you how to create a new layer. So in AutoCAD, for creating a new layer, we can move to the layer properties icon. And here we can click this icon. And here, if I need to create a new layer called demo, I can just name it. And we can just select a color as per our requirement. And if this is the color I need, I can click on OK. And we can see that a new layer called demo is created. And after creating a layer, we can click on the close icon, and we can see that here for this particular drawing, I have created so much layers. So not every layers are important. Some of the layers are already within this document as per the client drawing that is used in this drawing, but we not need all of these layers, and we need just these two set of layers, that is for CAD utilities that has to be drawn using polyline, and the other set of layers that are drawn using line command. So first one is wall layer. So once we create the layer called wall, we can see that in this drawing as per the client provide, we can see that all of these black hash denotes the wall area. So in this drawing, we can see that which all areas the walls are located. So here we can see that for the outer walls, much thicker walls are provided, and for the inner walls, thinner walls are provided. It's for as per our requirement, the basic concept is that the outer walls are of 9 inch and the inner walls are of 4 inch. So once we convert it into this figure, we can see that the walls are marked as per the requirement, and we need to give this lines as wall layer. So here the wall layer is shown using green color, and if we click on select similar, we can see that all the wall layers are highlighted. All the lines that are drawn using wall layer are highlighted. So here we can see that I haven't provided the wall line over some of these areas such as openings, such as windows, doors, ventilators and all. So the basic reason is that since these all gaps denotes, that is, if we look onto this figure, we can see that windows are present over these areas, door is present over these areas, and ventilator are present over some of these areas. So all of these areas are to be provided using zero line. That is, if we select this line, we can see that the layer is zero line, and it is also drawn using line command. If I click on select similar, we can see that all of these joineries, that is all of these openings, are denoted using zero line. And in those areas, I haven't provided the layer called wall. So instead of wall, we need to provide zero line for the openings such as walls, doors and ventilators. So once the wall layer is properly provided, we can move on to the next layer, that is column. So in the Excel, we can see that for my particular drawing, the column dimensions are 12 inch by 9 inch. So if we convert, and that is, we'll be drawing this plan using centimeters unit. That is, the units will be marked as centimeters. So if I convert 12 inch and 9 inch into centimeters, we'll be obtaining a dimension such as 30.5 and 22.86. So here I have drawn the columns. That is, this red rectangle denotes the column layer. And here we need to focus that the column should be drawn using the rectangle command itself, and it should be assigned in the layer column. So once the column is drawn, we can see that if I click on select similar, I have arranged the columns like this. If the column is not denoted in the client drawing, we need to provide the column as per the requirement. Like if the column is of size 23 centimeter by 23 centimeter, which is a little bit less, and then the spacing should be 2 to 3 meter. And in our case, the dimensions are 12 inch by 9 inch, and hence the gap can be 3 to 5 meter. That is, it should be less than 5 meter. So the columns are so arranged as per this requirement, and we can see that the columns are provided in the center figure. So the third layer is coming on to the next few layers, that are outer beam, inner beam, C beam, outer C beam, and plinth beam. All of these 5 layers are different types of beams. So for drafting and moving to estimation, we'll be doing both architectural drawing as well as the structural drawing for each of these floors. That is, in my document, my number of floors are just ground floor only. So I need to draw just ground floor. And the reason for me to draft the headroom plan is that here for parapet and headroom, the option is provided as yes. So I need to draw the headroom too. So here we need to draw the structural drawing, such as for ground floor, we need to draw 2 different types of set of beam column layout. One is the plinth beam column layout, and next is the ground floor beam column layout. So what is plinth beam column layout? This set of beams and columns are located in the foundation level. That is, these are a component of ground foundation, and it is situated below the ground floor, below the ground area. And what is a ground floor beam column layout? It is situated in the roof level of the ground floor. Um, that is over the that is along the roof level of the ground floor. So for drawing the plinth beam column layout, once we create the architectural drawing, we can make a copy of this drawing, and here we can see that a beam needs to be provided along each and every walls in the architectural drawing. That is, a beam have to be provided along the bottom of each and every wall. and the width of each and every beam should be 23 centimeter. Even if it is a 9-inch wall or 4-inch wall, the beam should be of 23 centimeter width. And once we draw the plinth beam as per the requirement, that is as per the walls arranged over this architectural drawing, we'll be getting one such drawing, and the columns are columns denoted over here are just a copy that I obtained from this architectural drawing. That is, once we click on a column and click on select similar, we can make a copy as per this, and clicking on this base point, we can shift the columns into this drawing. And all of these layers should be assigned the plinth beam layer. So that's about the plinth beam. And the next set of beams, that is outer beam, inner beam, C beam, and outer C beam. All these 4 type of beams will be present over the next set of drawings, that is ground floor beam column layout. So first one is the outer beam. Like the name denotes, the outer beams will be situated in the outermost part of the building. So if we look onto this architectural drawing, we can see that these are the outer walls of the building. So all of these beams should be. So an easy way to prepare the ground floor beam column layout is just to take a copy of the plinth beam column layout and change the layers as per the requirement. So for creating the outer beam, we can see that all of these outer walls should be considered as outer beams. So outer beams. So we can see that if this line is selected, we can see that it is assigned outer beam layer. And if I click on select similar, we can see that all the outer beams are selected over the ground floor beam column layout area. And we can see that over this small portion, another set of beams are provided. It is named under outer C beam. So what is outer C beam? When we look onto this architectural drawing, we can see that over this small portion, we can see that no wall is provided. So like we already discussed, we'll be providing beams only where the walls are provided. But in this case, we cannot just cut off the beams over this portion simply because the walls are not provided. But instead, we'll be providing another set of beams that is named under different category, outer C beam. So C beams are basically ceiling beams. So that is provided where walls are not given. So the beams provided over the area in which the walls are not provided are known as C beam. And since these beams are provided in the outermost area, it is known as outer C beam. And the C beams that will be provided within the building will be known as just C beam, that is marked using another layer C beam. And once we finish the outer beam and outer C beam, we can move to the inner beams. All the beams other than outer beam and outer C beams will be considered as inner beams. Like if we compare it with this plinth beam column layout, we can see that all the remaining beams are named as inner beams. And we can see that another set of beams, which is marked in yellow color, is located over some of these portions, such as these. So what is this? If I look onto the layer, we can see that it is denoted as C beam. So like I already said, the beams that are provided over the area in which the walls are not present is known as C beam. And if we compare in this figure, we can see that in ground floor beam column layout, we should not provide the beams after cutting it by such junctions. We should connect each and every such corners using the layer known as a C-beam. And for C-beam 2, the width should be 23 centimeter. Over the beam should be of thickness 23 centimeter, and the corner should be joined using C-beams. And here we can see that if the span of the slab is very huge, that is, if the span of the slab is over 4 meter by 4 meter or 5 meter by 5 meter, no such slab can be provided without any beams in between. In such cases too, we'll provide C beams in between. That is, if the span of the slab is very huge without any beams in between, we'll provide a C beam along its center. So here also we need to copy paste the set of columns into this beam column layout too. So like that, we completed the plinth beam column layout and ground floor beam column layout. And coming on to the architectural drawing, we need to assign the remaining layers. That is, here and the remaining layer is compound wall. Compound wall will be provided only if it is marked as yes in the Excel sheet. So here we can see that adjacent to the compound wall, it is given as yes. So that I need to provide a compound wall. So in my figure, no compound wall is mentioned in this. So for that, if the clearance is not provided in the client drawing, and the basic concept is that the ideal clearance provided by us in the UTech projects are 3 meter. So here this layer is a compound wall and it should be provided within a clearance of 3 meter from the building if it is not specified in the client drawing. So after that, coming on to the other set of layers that has to be assigned, that is commonly called as CAD utilities. And here, all of these layers mentioned over here are to be drawn using polyline. Uh, uh, like the layers that we mentioned earlier, that is wall, beams, compound wall and all, that can be drawn using the line line, just command using polyline. That is, if I click on properties, I can see that the wall layer is assigned under the command line. So the remaining set of layers, that is CAD utilities, are to be drawn using the command polyline. And these are case sensitive while doing estimation. What the meaning of this is that while I add the layers such as CAD utilities such as anti-skid, kitchen dado, kitchen finish and all of these should be named in a specific format. That is, if I type all these in the lower case, I should repeat the same in the estimax software too. If I use block letters over here and I use lowercase over in estimax file, it won't work. So it is case sensitive, meaning the case used in AutoCAD should be the same while using an estimax software. Moreover, and the space which we provided in between specific words such as kitchen and dado, we need to provide a space in between kitchen and dado. If we club this two words within a same word, that is without providing a gap between kitchen dado, it won't work while taking the estimax file estimation. So we should provide the gap in between each and every words like mentioned in this page. So that is, we should provide a space between outer and plaster and line like provided in this format. And coming on to the first CAD utility, which is anti-skid. So anti-skid is basically provided in the toilet areas, the toilet floor areas. So if we can see that this is a toilet and this is also a toilet. And if I click on this line and I select the anti-skid layer and I click on select similar, we can see that the line anti-skid is drawn using, and if I click on properties, we can see that the anti-skid layer is provided using polyline command and it is provided over the area denoted as toilet. So in the toilet areas, the anti-skid should be provided along the floor area. That is along the floor area mentioned as such. And the next layer is kitchen dado. Kitchen dado and kitchen finish are to be provided in the kitchen area. That is, if we look onto the client drawing, we can see that a slab is provided over this corner and it has to be mentioned in the drawing too. So the slab is basically drawn using the layer kitchen finish and dado. Basically, the dado means the tile work. We can generally we can see that in our kitchen areas, we can see that tile work will be provided for a specific height over the slab, which are provided in the kitchen area. So the same concept is used here. We can see that if this is the kitchen finish, which is basically the kitchen slab, a tile work has to be provided over its wall areas. So that is this layer. We can see that a polyline is provided over the edges in which the kitchen kitchen finish is present, and it is also drawn using polyline command. That is the concept of kitchen dado and kitchen finish. And the next line is toilet dado. Once we provide the anti-skid in the toilet areas, the next one is the toilet dado. Sorry, and if I click on select similar, we can see that the toilet dado is basically the tile work provided over the wall areas of the toilet. So since the tile work will not be provided over the openings such as doors, it is the same polyline is cropped over this area, that is cropped over the entrance of the toilets as well. That is, we can see that the polyline is having a break over this opening areas. So this is mentioned as toilet dado. And the next one is wash dado. In my figure, I don't have a washroom. And if in the drawing provided to you, you have a specific room called washroom, we need to provide the wall areas over similar to the toilet dado. We need to provide the wash dado over the wall areas of that specific room called washroom. And the concept is similar to that of the toilet dado. And the next one is the plinth line. So, like we know, plinth line denotes the projecting base of a building. Projecting base means it will be provided along the outer walls of the building, and it will be provided at a specific height. And if I select the polyline called plinth in my drawing, I can see that the plinth is provided along the outermost walls of the building. And in this case, since near to the entrance, steps are provided. And in these steps, the plinth line should follow the topmost step. Since the topmost step is the same height as that of the floor level of the building, the plinth line should follow the topmost step, and the remaining step will be of lower levels than that of the plinth line. So the plinth line should follow the topmost step. And that is regarding the plinth line. And the next line is outer plaster line and outer plaster deduction. So what is outer plaster line? The plaster line that should be provided along the outermost end of the building is known as the outer plaster line. In my figure, we can see that the outer plaster line is provided as such. Since this is the outermost face of the house, we need to provide the outer plaster line over this area. And the next one is the outer plaster deduction. Outer plaster deduction is that we know that the plastering will be provided over the wall areas, right? But in some cases like this, here the no walls are present over this area. And hence we need to deduct the plaster line from that small portion. So for that small area, I'll need to provide outer plaster reduction line. So outer plaster line is basically provided along the outermost side of the building. And for the areas in which the walls are absent, we need to deduct them using outer plaster reduction line. And some cases, if the porch is present, that is car porch and all, the porch is present, and in that case also, walls may not be present over its ends. So in that case also, if the slab projection is greater than 3 meter, we need to provide outer plaster deduction. And if the slab projection is of very small, that is 1 or 2 meter, we can simply provide outer plaster line, and we need not provide outer plaster deduction. So after completing outer plaster line and outer plaster deduction, next one is the inner plaster line. So inner plaster line is the line that has to be provided in each and every room. So if we select this room, that is master bedroom, if we click on this line, we can see that it is inner plaster line, and it is provided in a closed manner. That is, the plaster line will be provided over the openings too. That is, if a door is present over this portion and this portion, I need not cut at these sections. Instead, I can provide the layer over these openings too. So if I click on the inner plaster line and click on select similar, we can see that the inner plaster line is provided separately for each and every room. Okay, so after completing the inner plaster line, we can move to the next line. That is parapet and terrace waterproofing. Both parapet and terrace waterproofing lines are to be provided in the headroom plan. So what is headroom plan? Like we already discussed in my drawing, the head parapet and headroom is shown as yes. That is, I need to draft the headroom plan and headroom beam column layout. So for drawing the headroom plan, we can just copy paste the location of the headroom. That is, the headroom should be located over the stair areas in the ground floor like this. And before going on to headroom, one more layer is there. That is, we need to denote the slab that will be placed over the roof layer of the building. And that slab is denoted using the layer zero line, zero layer that is drawn using polyline. If I click on the properties, I can see that the specific layer is marked using polyline. And this specific zero layer line is known as the slab of this particular floor level. And uh, if I have a certain notations like duct and stair area, we need to deduct the slab at those areas as well. So after drawing the slab area over the entire slab section, we need to provide the slab deductions too. For duct, we need to provide slab deduction. That is, if I click on the polyline command, we can see that a zero L is provided over this duct area since it denotes a slab reduction in those areas. And also in this stair region, we can see that a slab reduction is provided in this slab area. So once the slab layer is created, we can move on to the headroom plan. And here we'll just need to copy paste the outermost layer of the building and the stair region like shown in this figure, and near to the corners of the stair room, we can provide the wall layer. That is, if I click on select similar, I can see that wall is provided over this area and 4 columns are provided along the corners of the headroom as well. So we can see that another set of column is marked over these two ends, that is FC. FC denotes floating column. That is, floating column denotes a column that is provided at a particular level. If we can compare to the ground floor level, we can see that no such columns are present in the ground floor level. But we have added 2 additional columns in the headroom plan just for the headroom. So that additional columns need to be marked as FC, which denotes floating column, and the layer is similar to the column as well. And here the two set of additional CAD utility, that is parapet and terrace waterproofing, is provided in this layer. If the terrace waterproofing here we can see that we have to provide, since it is marked as yes, we need to provide waterproofing in the parapet area as well. So if I click on this line, we can see that the parapet is provided over here. It is also drawn using polyline command, and the parapet is provided over the area in which the headroom is absent. So the remaining area is marked using parapet, and the headroom and the terrace waterproofing also is provided in the floor area of the terrace slab. Okay, so once both of these are completed, we need to draw the beam column layout of the headroom as well. So since this is the uh, structure of the headroom, we can just select the outermost layer and copy paste the 4 set of columns over here. And after placing the set of columns, we can just offset the line into 23 centimeter thick. Like we already discussed this, and the width of the beam should be of 23 centimeter. and I have assigned the beams as outer beams. Since all of these sides denotes the outer end of the headroom, we should assign all of these beams are outer beam. Once the architectural drawing and structural drawings are completed, the next step is the uh, genre table. So the table denoted over here is named as the genre table, and the format, the basic format, that is the headings such as name, length, height, and CAD notation are to be followed, since this is the format used in estimax software. And here in the name denotes whether it is a door or window or ventilator and so on. And the length, what this actually denotes is the width of the joineries. That is, if in the case of first row denotes the door, which is the main door, we can see that the length is marked as 91.44. So here we can see that this is the main door, and if we measure its width, we can see that it is 91.4. So the same length is so the same width is noted here as length, and the height is usually same for each and every case. That is, for doors the height is normally 210 centimeter, and for windows the height are normally 120 centimeter. For kitchen windows, apart from normal windows, the height will be a bit low, and hence it is selected as 90 centimeter. And the case of ventilators, it can vary. It can be between 50 centimeter to 60 centimeter. So, and based on the different width of the doors and windows and so on, I have marked different types of doors as D1, D2, and D3, depending upon the variation in the width. That is, the same is noted over here. If the D1 is 91.44, if the same width is used over here, I need to name it as D1 itself. So the same CAD notation are to be used in this drawing, and each and every uh, text that is used over here should be of single line text, not M text. That is, if I show it in this figure, I can see that in the drawing provided by the client, the text are done using mtext command. And for our drawing, all of these text should be in single text command, and hence it is shown over here in the format as text. So like that, we have completed the genre table, the layer assigning method, and drawing the structural components of each and every architectural flow. So that's all for today's session. Do anyone have any doubts?
Okay, Nirmala, thank you for the session. Okay, so if anybody have any doubt, they can ask, or else we can wind up the session. Okay, thank you all. Thank you, Nirmala.
Thank you. Thank you.